All right, now I'm going to give you some hints for graphing. I'm having to learn to use this thing again with yet another computer. Equations. All right, so the first thing you want to do is you don't want to graph every single flipping point, even all the unit circle angles. You just want to plot convenient. Oops. And you only want to plot enough so you can see a pattern. And it's just going to take practice. So the first thing you want to know is, you need to keep in mind, is that if you're talking about sine of an angle, the convenient angles are 0, and then pi over 6, and then pi over 2, and then 5 pi over 6, ... right? Well, let me put pi in there so you can see the whole pattern. Pi, and then you just keep going. If you're talking about cosine of an angle, the convenient angles are 0, pi over 3, pi over 2, 2 pi over 3, pi, and you keep going. So the reason you're using 0 and pi are easy because they're either 0 or 1 for each one of them. You choose pi over 6 for sine because that's sine's a half there, and you don't want to deal with square root of 3 over 2. You want to use a half. And for cosine, you use pi over 3 because you want cosine to be a half. So let me just fix something. All right, so the first thing you start off with is, so let's do one where we're just going to do one. You're going to have 2 on the assignment. Y'all just need to practice these. If I give you that r, sine of an angle equals, say, -3. What you need to do, so this is kind of hard. This is not where we normally start. This is harder. If you go ahead and you solve for r is equal to -3 over sine of the angle. Well, I can pick angles that the convenient angles. So I just put in my convenient angles: 0, pi over 6, pi over 2, 5 pi over 6, pi. And I'm not going to put in too many points. I'm not going to fill this whole thing. I'm going to see if I can get a pattern. Well, you can't have division by 0, so this is undefined. And please put undefined. Don't put a dash or something weird. Make it clear. You don't have to write out the whole word, but put enough letters there so I can tell that it's undefined. We put in pi over 6, then it's -3 divided by 1/2, which means that's equal to -6. How many halves are in 3 cups? 6. So it's -6. You put in pi over 2, it's -3 divided by 1, which is -3. And put in 5 pi over 6, it's still a positive half, so it's still -6. And then at pi, it's back to being undefined. You have division by 0. So when we go to graph this, that's enough points. You want a minimum of 3 points for something like this. This is a really simple one. And if you look at this, you should know what it is, because if you were in the previous video, you should have learned or last year you should have learned, and you should have refreshed your memory on what r sine theta is. That's just y. So this is y equal to -3. So we should go 1, 2, 3. 1, 2, 3, right? That's that same point. So it should go through there and it should be a horizontal line. Well, let's graph this out. At pi over 2, that's up here. We're coming to this angle pi over 2, right? It is a -2, so we go across, and indeed, this is the correct point. I did it right. My computer doesn't think I did it right, but I did. I did it right. That's correct. Okay, let's do another point. Well, at pi over 6, we want -6. So at pi over 6, that's this, right? There's pi over 6. We want to go across to -6. And the circle only goes to 5, so it's going to be out beyond like right about, about there or so. So we'll put a point. We'll get there in a minute. You'll see what I'm talking about. And then we want 5 pi over 6. Well, this is 5 pi over 6 here, and we want a -6 again. Oh, so that means it's going to be out here somewhere. Oh, so if I just draw in a horizontal line, no, I'm going to have trouble moving it, of course. It's it never wants to do it. You have to draw it through it or it doesn't work. Okay, so let's try drawing it in. I'm going to draw it like this, and then I'm going to shift things. Maybe not. Maybe it'll work. He doesn't like that. Okay, trying again. Try one more time. And then I'm going to give up and just draw it by hand. I think I'm just going to be drawing it by hand. It's locked. It won't let me. So here I go, drawing it by hand. It goes like this. So you'd have a point here and a point here. And there's your 3 points to show a line, mainly because it's just a weird line. And then if we did one where it was, r, let's choose a different color. Let's do green. If I say it's r cosine of theta equals, let's say 4 just for grins. It's going to be hard to graph, but that's okay. Well, this is an x. That means x equal to 4. That's x equal to 4. It's right here. So I know that it's going to be a vertical line through here. And that one should be easy to draw. Should be. There we go. Right. Here it is. Well, let's confirm that we've got this right. If we come over here to, this is going to be r is equal to 4 divided by cosine of theta. And we start at 0. Well, cosine of 0 is 1. So this is going to be 4. If we go to pi over 3, because it's convenient for cosine, then this is going to be 4 divided by 1/2. 4 divided by 1/2 equals 8. And then if we go to pi over 2, we have division by 0. That's undefined. And then we would go to 2 pi over 3, which would be 4 over -1/2 equals -8. And then we get back to pi, and pi is -1, so it's -4. Let's look what these points would look like. So we're talking about, well, 0 is obviously this point. And then if we do pi over 2 is undefined, that doesn't help us, but we do 2 pi over 3 is -8. So this is 2 pi over 3, and we go all the way down, and so it would be like -8. It would be somewhere down like this. Down here somewhere. And that makes sense. So if we go, we stretch our little line out a little more. Oh, there it is. It hits it. That's good. And then we got pi is -4. That puts us back over and across again. Oh, we could have done pi over 3 also. Pi over 3 is +8. So let's do pi over 3. Here's pi over 3. Pi over 3, if we go out, oh, look, it's right there. That makes sense. Doesn't make sense why that's doing that. But, so that's the line. So you can figure out what they are and draw them. I'm not so concerned about that for calculus. We need to move on to the other ones, but I'm just going through everything you're supposed to learn already. All right, next we go and we look at things that make circles. And there are 2 main kinds. There are kinds that are centered on an axis, and there are kinds that are centered on a pole. So if we have something like, and it's just r equal to 3. R equal 3 means the radius is always 3, which means, guess what? It's going to be a circle of radius 3. That was easy. And if you're doing the radius, you just put 3 and it goes all the way down, and we're going to go, we'll say 0, pi over 2, pi over 3, pi over, well, that wasn't quite right. How about we do it? Pi over 6, go in order, pi over 6, pi over 4, didn't work out right, pi over 3, pi over 2, pi, and it just keeps going. It's always 3. That's one kind, and it's centered at the pole. The other kind of equation, it's shifted off, and it's centered, it's symmetrical across one of the axes. And let's do, what we do, r is equal to -2. I think I've already kind of done that. Did I already do this one? Hang on. I gotta see what I've actually done, because now I can't remember. We graphed the one in the last thing. We graphed a 2. So now we're doing -2 cosine of theta. Well, what that means is that, so you have, this is -2 times whatever it is. So if we go for 0, it's 1, so it's -2. And then if we go, we're going to do our convenient values, pi over 3, pi over 2, pi, 2 pi over 3, I did that wrong. This pi over, that should have been 2 pi over 3 right there. 2 pi over 3, pi, that's better. And then 4 pi over 3, and then 3 pi over 2, and then 5 pi over 3 and 2 pi, and I just want you to see what happens when we do this in the tables. You put in pi over 3, that's -2 times 1/2, which is -1. You put in pi over 2, that's -2 times 0 is 0. That's really messy. Put in 2 pi over 3, and you get -2 times -1/2 equals 1. And then for pi, you get -2 times -1 equals 2. And then 4 pi over 3, it's still negative, so that's a -1 again. Oh, not -1, +1. It's a +1. This is a positive, no, that's 0. This is a, when we get over there, the cosine is back to positive, so this is back to a -1, and this is a -2 again. Ooh, look at that, the pattern repeated. Oh, let's go see what this does. So at 0, it's -2. So instead of being on the positive side, it's a circle on the negative side. We graphed before, we graphed r equals cosine, 2 cosine, and so it was on the positive side, the positive x-axis. This is on the negative x-axis because it is a -2. I don't know why it's doing that, but why is it hates me? I don't know what I'm doing to press on this, but I apparently, oops, didn't mean to do that. I'm trying to find myself. I didn't want you to do that. I don't want you to do anything except just let me graph this point. Here we go. Stop it. Right there. Point right there. And then we have -1 at pi over 3. So pi over 3, you come over, it's -1 down there. I don't know what's going on. Why is it doing this? Let's zoom in. View. Zoom in so I can graph this silly thing. Let's see if it likes it better if I zoom in. Okay, so I have pi over 3, which is this one right here. I got 1. And then at 2 pi over 3, I got a +1. It's this one right here. It's a +1. And so it's a circle that goes like this. Well, it should be a circle. If I could draw it as a circle. It's going to take more practice with this pen. Anyway, it's a circle. So all the circles have the same form. And if it's just a radius, that means that it's going to go through, it's going to be centered at the pole. And if it's a cosine, it's going to be symmetrical across the x-axis. If it's a negative, it's going to be on the negative x-axis, part of the x-axis. If it's positive, it's on the positive side. Y's are sines, so all the sines will be circles that are symmetrical across the y-axis. And then we get angles, and angles, when you graph them, just make lines. They're more lines. So when you get to those, y'all can fiddle around with those. I'm not going to spend a lot of time on those. Okay, now the next thing we got is all the weird limicons. And let's start with some of the ones that were in that Christmas homework you were supposed to do. And I'm going to graph different ones. Yeah, okay. So we're going to do, this time we're going to do r equals 2 plus 2 sine of theta. And we're going to use the convenient values for sine, which are 0, pi over 6, pi over 2, pi, 5 pi over 6, pi. And I'm going to want 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. That doesn't look like 11, it looks like a pi. Yeah, 11, there we go. All right, when we plug in 0 into sine, it's 0. So this is just 2 plus 0, which just gives me 2. I should write that down. Hang on. 2 plus 0. 2. At pi over 2, it's 2 plus 2 times 1/2. It's 2 plus 1, which is 3. Pi over 2 is 2 plus 2 equals 4. At 5 pi over 6, it's still 3. At pi, it's 2. At 7 pi over 6, that makes it in the third quadrant, so it's negative now. So we now have 2 minus 2 times 1, or actually, it's 2 plus 2 times a negative 1/2, which means it's 2 minus 1 is equal to 1. At 3 pi over 2, it's a negative 1, so it's 2 minus 2 equals 0. At 11 pi over 6, it's still 1, and at 2 pi, it goes back to 2. So let's graph this and see what it looks like. But first, I am going to make it a little bigger. All right, so we start at 0. And so we're at the pole, and then at pi over 6, it is 3. Let me draw. And at pi over 2, it is 4. Come on, stop it. I don't know what I'm doing that it doesn't like. It doesn't like something. I gotta fix the settings, I think. At 5 pi over 6, it's 3. Stop it. At pi, it's 2. And at 7 pi over 6, it's 1. It's 1 here. And at 3 pi over 2, it's 0. 7 pi over 6, it's 1. And then it goes back to 0. Come on. And then at 0, it's 2. It wasn't 0 and 2. It wasn't 2 and 0. There we go. It's 2 and then it's 1 here. All right, so what does that look like? What's going on is you start at 2 and you go around and up and then back around till you get to pi, and then you have this little bitty bump, and then you finish up the bump. So in calculus, it's important to know where you're starting. That's my start. You're going around, you're going this way. The direction matters. And when you get here, that's at pi, and then to go this first part of this, the heart, that's between pi and 3 pi over 2. And from 3 pi over 2 to 2 pi, you're drawing the other little piece. Where you are on the graph at any given time is important. You have to know where you are. You have to know where you're starting. So you need to know the start. Oops. To know your start. You have to know when you get back, and you have to know where you are at any given time, because you're going to have to use that knowledge to do the calculus. And that is a cardioid. I don't care that you know the names. I just care that you know the patterns. And there are patterns to this. So if you understand what the patterns are, which we will go over in class, it makes this so much easier because you don't need to do as many points. You do a few points, you can graph them a lot faster. And it's going to take practice on your part. So y'all are going to have to practice for this. And that's a cardioid. And then the next thing we're going to go over is what happens. So that was when the two, y'all don't know if you noticed, but the coefficient and the constant in the equation, they gave you they were the same value. They're the same magnitude. Now it could be plus or minus, and we'll talk about the minus in a little bit. But it's going to take practice, and you're going to have to work at this. And then once you see the patterns, it gets a lot easier. So our next one we're going to try is 1 plus 2. So this time it's going to be R equals 1 plus 2 sine of theta. And for this one, we want the same convenient. We're doing all sines. You're going to do cosines on the homework, so it's okay. Don't worry. We're going to switch it up all over the place. You just have to get used to it. All right. Shifting down. And here we go. So convenient values, the same ones. 0, pi over 6, pi over 2, 5 pi over 6, 7 pi over 6. No, I want pi in there. Pi. 7 pi over 6, 3 pi over 2, and 11 pi over 6. And last but not least, oh, come on. 2 pi. Maybe. I think I need to go a little bit. There we go. 2 pi. And you put in, so now you put in 0, 0 plus 1 plus 0 is 1. And here it's 1 plus 2 times 1/2 is 1 plus 1 is 2. And then this is going to be 1 plus 2 times 1, which is 3. 5 pi over 6 is 2. Pi is back to 1. 7 pi over 6, that's going to be 1 minus 2 times 1/2, which means it's 0. And this is going to be 1 minus 2 times negative 1, which means it's 2. Back to, what did I do? Hang on a second. That's 0. Then it's 1. Oh, I guess I should put the minus in here like this. There we go. So I don't get confused. I was a negative 1/2. There we go. And then -1, which means it's 1 minus 2, which is -1. And then this is back to 0. And then this, at the 2 pi, we get back to 1. Now, I need you to pay attention, really close attention right here, where we had something weird going on. We had 1, 2, 3, 2, 1, 0, -1, 0. That is the part I want you to notice. Right there. This part right here, 0, -1, 0. So we were on the positive side on both those sides, but this suddenly we went into the negative. We went around the other way. That is the inner loop. You will spot that every single time. And we'll see the pattern shortly. But if we graph this thing, we will start at 1 on 0. I don't know why it doesn't let me just draw a dot there, but it doesn't like it. So let's get more. Let's get bigger. Okay, and then at pi over 6, it's 2. And then at pi over 2, it's 3. And then at 5 pi over 6, it's 2. I don't like that. There we go. And at pi, it's 1. And then look what happens. It goes to 0 at 7 pi over 6. So somewhere between here and here, it goes to 0. Right there. But then at 3 pi over 2, it goes to -1. So we go up and over. We go inside it. And then at 11 pi over 6, it goes back to 0. That's somewhere in between here and here. And then at 2 pi, it goes back to 1. So what's happening is, oh, I lost my pi over 6. Pi over 6 should have been 2. Like that. I keep losing points. I don't know why it just won't let me keep them all. It's being weird. Oh, that's because I have this one in the wrong place. Oh, I just lost. There we go. That's it. Okay. So what's happening is we start at 0. We go up and around. And this is a really rotten drawing, but I can do better when I'm not. Okay, it comes into 0, then it goes up to 1, comes back to 0, and then goes to 1. And I can draw this better when I'm not using this funky pen, but oh well. I'll have to practice it. And you can see that if you're doing this online with a stylus, you need to practice it because it's a lot easier with pencil. But if you're doing this, you're going to have to probably print out some graph paper and practice it, the grid paper. But this is a line with an inner loop. And that inner loop, why is that important? Because let's look at what this is what's really going on here. Let me make this a little bigger because this is the important one for y'all to understand why we are bothering to learn to graph. It's so that you can actually understand how to do calculus, because in calculus, we're going to find arc lengths, and they might ask you for the arc length of the loop, the inner loop. What if they only want the arc length for this part, just this part right there, the inner loop? Well, that means you only need to integrate when you're doing the arc length formula. You only need to integrate from 7 pi over 6 to 11 pi over 6. But if you don't know where this is graphed at, you're not going to integrate the right parts. And the other thing they'll do to you is they'll say, well, what is the area of the inner loop? Or even worse, they'll ask, what's the area between the outer loop and the inner loop? What is that area? Well, the only way to get that is to get the whole thing and subtract out the loop, but it's not that simple. Let me show you why. Remove my highlights. And let me show you why. Because what's going on is when you go to graph this, this is the rate. I'm going to draw this as a radius. So this is the radius of 1 at 0. And then as you go across, as you shade this in, suppose you are shading this in, but instead of rectangles like the Riemann sums, you're going to do slices of pi. But we're shading this in, we're coloring. Do you see how the radius is changing as I go through here? as I go around the unit circles, remember this is positive, we're going this way, the radius is changing. But look what I'm shading in. I'm not just shading in the outer part, I'm shading across that loop too. So in reality, when you draw that, when you go and do this, when you're looking for an area, you have a radius that's going to shade. We're going to do something like a Riemann sum, and we're going to shade it, but we're going to shade all the way through the loop. We're going to shade all the way over here. And then when we get to here, we're going to come all the way from 7 pi over 6 to 0. And then, then what we're going to do is we're going to shade inside the loop. Or it's already been shaded by all the blue, but now I'm going to shade it again by going all the way around on its radius for this piece right here. And then we finish up with shading this part. And that's why you need to know where you're at, because we just colored in the loop not once, but twice. So in order to find the area between these two, we have to subtract 2 of the loops. Or we have to really understand this because it matters. Okay? So, recapping, my graph would be like this, and then it would be 2, 2, and then 3, and then 2, and then 1. So it goes around like this. That's 1. That's not the right point right there. Around like this. Comes into 0, goes up to 1, comes back to 0, and finishes up. And so we start here and go around. I think that's enough for one video. This will get us started. And in class, I'll show you how all this fits together after we do a little more practice and understand it.